Hello and welcome. Today we are going to be learning about topographic maps. As you no doubt know, we live in a three-dimensional world. We have places with mountains and valleys. We have steep cliffs and vast plains of nearly flat ground. Now, it is one thing to go and see these things in person or to fly over them in an airplane. But if you are a small human being standing on the ground in the middle of a place like the Grand Canyon, or among the vast peaks of the Himalayas, how would you know where you are, and how would you know how to get from one place to another? Obviously, you are going to need a map. But not just any map. You need a map that not only shows where you are, but also shows you the shape of the landscape. What you need is a topographic map. So what is a topographic map? A topographic map is a scaled down two-dimensional representation of our three-dimensional world. Essentially, a topographic map allows us to show three-dimensional surfaces on a flat piece of paper. Now, before we get into more detail about topographic maps, we need to talk a little bit about points of view. When we are looking straight down at an object from above, as if we were looking at it from space, we say that we are viewing things in plan view, which essentially is the viewpoint we have in most types of maps. Here in this particular view, we can see that we have a green polygon with a dark green square in the middle and a black arrow next to the square. What we can't tell in this view is if these are flat objects on the ground surface or if they have some dimension to them. Another way we can view an object is in profile view. Essentially, we are looking at the object from the ground level. Here we can now see that the green polygon actually does have some depth to it. We can also see that the dark green rectangle is actually a cube-shaped structure on top of the lighter green block. Notice that we cannot see the black arrow, which suggests that it might be a flat object. One last way we can view an object is from an oblique, or what we sometimes call a perspective view. This is a view that you might get if you were flying over a city at a low altitude so that you were looking down at the city from an angle rather than from directly above. Here in perspective view, we can see the dimensions of both the light green polygon block and the dark green structure on top of it. We can also see that the black arrow is a flat feature sitting on top of the surface of the lighter green block. Now, when we are looking at topographic maps, we will primarily be viewing things in plan view. However, we can use the information contained within a topographic map to construct profile views so we can more easily see the shape of the land surface. Later in the semester, we will also be using satellite imagery available from Google Earth to study various geologic features in plan, profile, and perspective views. For now, though, let's learn a little bit more about understanding and interpreting topographic maps. To help us better understand what a topographic map is and how to interpret it, we are going to start by using Google Earth to look at a landscape in detail from plan, perspective, and profile viewpoints. For those of you who aren't familiar with it, Google Earth is a free software program that allows you to view satellite imagery that has been draped over a three-dimensional model of Earth. It is a very useful and very powerful tool for exploring our planet, and we will be using it extensively in future labs. So let's take a look at a small little mountain in the northeastern corner of California called Dome Mountain. Here we're looking at Dome Mountain in plan view, far above Earth's surface. Doesn't really look like much from here, does it? As we zoom in closer to Dome Mountain, still in plan view, you can start to get a sense of the shape of this mountain judging by the shadows on the ground surface. The real power of Google Earth, though, is that we can look at this mountain from a perspective view to get a much better look at its shape. From this perspective, we can see that the Dome Mountain really is a dome-shaped mountain. Actually, Dome Mountain is a small volcanic peak, and we can see as we fly around the mountain in Google Earth that there are small valleys and ridges around the base of the mountain. We can also see that the mountain is longer in one direction than the other, and that it has a fairly long, narrow ridgeline along its crest. As we continue to fly around Dome Mountain, we get a better feel for the shape and size of this mountain. However, If we were out in the field, standing on the ground next to this mountain, how would we be able to tell what the other side of the mountain looked like? Without a computer and an internet connection, we wouldn't be able to use Google Earth to see a complete picture of the area we were standing in. Here is where we need a topographic map. So let's have a look at Dome Mountain as it appears on a topographic map. Here in plan view, we see a typical topographic map. There are lots of lines in different colors, but the main thing we want to focus on right now are the brown lines visible on the map surface that appear to run in rings around the mountain. These are contour lines. So what are contour lines? A contour line is a line of equal elevation that is drawn on a map to represent the altitude of that line above sea level. So let's examine these lines a little bit closer. We can use Google Earth to look at these contours in perspective, which is something we couldn't do if we were looking at these on a flat map. As we move our view to look at the contour lines from a perspective view to a profile view, we can see that the contours form horizontal lines across the side of the mountain. Here is where we really can see that these contours are lines of equal elevation. If we look at this line here, we can see that all of the points along this line are at the same elevation. In this case, the label over here tells us that this is the 5,800-foot contour line. In other words, every point on this line sits at an altitude of 5,800 feet above sea level. Now, there are a couple of important things to note here. First, you can see that there are lighter colored contours and darker colored contours. The darker colored contours are called index contours. These contours are darker colored so that you can see them easily, and they are labeled to show the elevation of that line. Between the index contours are the regular contour lines. You'll notice that all the contours are equally spaced vertically. The vertical difference between a contour line and the next line above it or below it is known as the contour interval. On this particular map, the interval between contours is 40 feet. So, if we start here at the 5,800-foot index contour, we can count upward: 5,800, 5,840, 5,880, 5,920, 5,960, and finally 6,000 feet. If you know the contour interval, you can determine the elevation of any point on a map by simply counting upward from the nearest index contour. The important thing to remember here is that all contour lines are equally spaced vertically. You gain or lose the same amount of elevation anytime you go up or down one contour line.